These rocks look ordinary enough, but shine ultraviolet light on them and they begin to glow. They fluoresce. The same thing happens when UV light falls on other objects too. Tonic water contains quinine, which fluoresces. And washing powders, which contain chemicals called optical brighteners, make garments look whiter than white. Ultraviolet light isn't part of the visible spectrum, so our eyes can't see it. It lies beyond violet. But we can detect its presence by the effect it has on fluorescent materials. When UV radiation falls on these rocks, its energy is absorbed. It's then re-emitted at a wavelength we can see, which causes the glow. Invisible radiation is effectively shifted into the visible region. Fluorescent tubes rely on this shift. The tube is painted with a substance which fluoresces when bombarded with UV rays. Without a coating, all you see is a small amount of visible blue. The remainder of the radiation is invisible until it strikes the fluorescent coating, which converts it into light we can see. Sunbeds use ultraviolet lamps for tanning. But UV carries more energy than visible light. It can be damaging to skin cells, so for safety, it's important not to use sunbeds too often. The sun also emits ultraviolet. The highest energy UV rays are absorbed by a chemical in the atmosphere called ozone. But in areas of the world where the ozone layer is thinner, damage to skin cells is on the increase. The electromagnetic spectrum is a continuous spectrum of waves, from very short waves at one end to very long waves at the other. Visible light is just a tiny part of it, with a range of wavelengths between 400 and 700 nanometers. Ultraviolet radiation has a shorter wavelength than visible light. It has a wavelength of about 100 nanometers.